we're going to talk about is Charles's Law. So what Charles's Law tells us is when pressure is constant, volume is directly proportional to temperature. So if I increase the temperature, my volume is going to increase. If I decrease the temperature, my volume is going to decrease. So if you go to Moodle and you go to the video below this one, it shows me demonstrating Charles's Law. Now, if I'm looking at my equation for Charles's Law, it tells me my initial volume divided by my initial temperature is equal to my final volume divided by my final temperature. Now, just remember, your units for volume need to be the same for initial and final. And my units for temperature have to be in Kelvin. So now let's try a sample problem. It says, on hot days, you may have noticed that potato chip bags seem to inflate even though they have not been opened. If I have a 250 milliliter bag at a temperature of 19 degrees Celsius, so my volume is going to be 250 milliliters at 19 degrees Celsius. So, in order to get from Celsius to Kelvin, we add our 273, and we get our 292, which is the initial temperature we're going to be working with. It then says I leave that bag of chips in my car, which has a temperature of 60 degrees Celsius. So my 60 degrees C, once again, I'm going to want to convert that to Kelvin in order to get the temperature I can work with, which gives me 333 K. What will the new volume of the bag be? Now, what I had just talked about before was there is a direct relationship between these things. So if my temperature is increasing from 292 to 333, the volume of that bag should be increasing as well. But we got to figure out, all right, so what will that new volume be? So let's plug my numbers in. I have 250 milliliters over 292K is equal to some number over 333 Kelvin. So 250 divided by 292. And that will give me 0.856 I'm at milliliters over Kelvin for my units. It's equal to X over 333K. In order to get that X by itself, I'm going to multiply both sides by my 333K. So that's going to cancel out. My Kelvin unit is going to cancel out. And we're going to end up with an answer of 285.1, so I'm just going to round it to 285 milliliters. Now, if we're looking at it, that did show an increase in my volume, which means overall we can pretty much assume that we're correct. So I want you to try some of those Charles' Law problems and let me know if you have any questions.